right, page 211. This is geometric sequence and series. A geometric sequence is a sequence where the ratio of any terms to its preceding term is a constant value. So the ratio is a constant value. It's different than arithmetic sequence and series. Okay? So for example, if I had 3, 6, 12, 24, and 48. Is that arithmetic? No. Arithmetic would be 3 plus what is 6? 3. Is 6 plus 3 12? No, that's arithmetic if it was, right? But it's not. So geometric, 3 times what is 6? 2. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. But it wants you to set it up as to a ratio. And so I'm going to show you, I know that's easy to see that it's times 2, but sometimes if you have fractions or if it's written in not such an easy way to see, I want you to also be able to write it as a ratio so that you can tell easily if it's geometric or not. So what you would do, you would take the 6 and divide by the preceding value, that's the ratio, and that equals 2. 12 divided by the preceding number, that's the ratio, is 2. 24 divided by the preceding number is 2. 48 divided by the preceding number is 2. Same thing as 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. But in a couple examples, you'll see why that's helpful to know how to also write it as a ratio. And why I took the time to show you that, okay? But a lot of the times it's easier just to go, yeah, you just multiply by 2 every time. So this would be called a geometric sequence. And what we did over here, these were the ratios. We made ratios. In the definition it said, a geometric sequence is a sequence where the ratio of any term to its preceding term is a constant value. So we made ratios and they were constant values, right? The preceding terms.
So if you have to write the ratio out, would it be 2x or?
No, the ratio is just, if I was writing the common ratio, we would say is 2, not 2x. That's like times 2, times 2, times 2, okay? So the common ratio and we call the variable is r when we get to the formula, is 2. You know how when we were doing arithmetic we had a constant difference, right? Well, when you're doing geometric, it's called a common ratio. In arithmetic, it's called a common difference. Geometric, common ratio. And then we still have a starting value, an a sub 1. We still have that as well. And in this case, the starting value, or a sub 1, is 3. Somebody said they had a question? Yes.
To do the geometric sequence, you need a certain amount of numbers to, like, can you have 3 numbers?
3, probably at least 4. I mean, you can't have 2. You need at least more than that, because if you just had 2, that could be anything. You know what I mean? Okay, so let's look at a couple examples and try to determine if they are geometric or not. First example is 3, 6, 9, 12, 15, a geometric sequence. Why not? Say it again. Exactly. If I were to set this up and find the common ratio, it's not going to be the same. 6 divided by 3 is 2. 9 divided by 6 is 1.5. 12 divided by 9 is 1.3, repeating. 15 divided by 12 is 1.25. I'm pretty good at that, right? I already had it written down. I already knew that. Is it arithmetic? It's arithmetic, but it asks us about geometric, right? So it's not geometric. I'm going to say no, because there isn't a common ratio. How about this one? Is 3 to the 5th, 3 to the 10th, 3 to the 15th, 3 to the 20th, a geometric sequence? Now, one thing you could do is you could figure out on your calculator, you could figure out what 3 to the 5th is, 3 to the 10th, 3 to the 15th. Those are going to be some really big numbers, right? Or we could set up the ratio like we did above. We could do 3 to the 10th divided by 3 to the 5th. And remember your rules when you're dividing and you have like bases that have exponents. Remember, the rule says keep the base and subtract the exponents the exponent of the numerator minus the exponent of the denominator, and that would give you 3 to the 5th. Okay? So that's for the first one. The next one would be, and you go backwards, right? So 3 to the 15th divided by 3 to the 10th would be 3 to the, what's 15 minus 10? 3 to the 5th. On the next one, 3 to the 20th divided by 3 to the 15th would be 3 to the 5th. Do they have the same common ratio? Yes. So is it geometric? Yes. So yes, because there is a common ratio of 3 to the 5th. I'm going to go ahead and make my notes complete. I'm going to write the ratios up above so that we have them. Is that zoomed in enough? Okay. Everybody cool with that? Okay. So just like what we did with arithmetic sequences, if we want to find a particular term in the sequence, instead of just continuing to figure out the next term in the sequence, we can use a formula, the explicit formula, to find the 10th term, the 50th term, the 100th term, the 1000th term. But it's going to be a different formula than the arithmetic sequence. So to find a term, in a geometric sequence, comma, you have to use a different explicit formula than you did for arithmetic sequence. And that formula is A sub n equals A sub 1 times r raised up to the n minus 1. A sub 1 is the first term in the sequence. R is the common ratio. And n is the term number you're looking for. Coolio? Alright, so let's put this into action. On page 212. Alright, find the 10th term of the sequence. And our sequence is 4, comma, 12, comma, 36. And that's all we have. So, Caitlin, on that one, there's only 3. So, you know our formula is a sub n equals a sub 1 times r raised to the n minus 1. We know it's that one and not the arithmetic one because it's a geometric sequence. Because 4 times what is 12? And 12 times 3 is 36, right? We're multiplying to get to the next term of the sequence. So this is the geometric explicit formula, not the arithmetic. We would use a different formula. So our first term of the sequence is 4. Our common ratio is 3. And n, the term number we're looking for, is 10. Super easy. So we're looking for a sub 10. So we're looking for that 10th term. If we knew the 10th term, we could plug that number in there. Sometimes what they give us, we need to do that. Equals, first term is 4 times common ratio of 3 raised up to the 10th term minus 1. So I'm going to take care of that, simplify what's in parentheses first. So that's 4 times 3 raised to the 9th power. What do I do? 4 times 3 or 3 raised to the 9th power? 3 raised to the 9th. Quit doing 4 times 3 first. You don't do multiplication before exponents. So 3 raised up to the 9th power is 19,683. And then multiply those together. And the final answer is 78,732. So that jumped quick. We went 4, 12, the third term's 36. You're just multiplying by 3, and by the time you just get to the 10th term, you're at 78,732. That's crazy. Questions? So easy. All right, on this one, find the 7th term of the sequence. We have 1, -3, +9. If that -3 confuses you, like, okay, what's the common ratio? If it confuses you, then just set up the ratio. So remember, you would do -3 divided by 1 is what? -3. And 9 divided by -3 is -3. Okay? So what's the common ratio? -3. What's your first term? 1. And what's n? 7. So I'll do this quietly. Y'all do it on your own, and you can check with mine as you go. If you don't put that -3 in parentheses when you raise it up to the 6th power, it's going to tell you that you get negative 729, which is not correct, because the negative is also being raised up to the 6th power, just like the 3 is. So that's really important. Anybody have questions on that? All right. Okay, let me show you one more that has fractions. And then I'm going to show you what happens when it gets a little tricky. So no questions on this? Okay, 213. Not during notes unless it's absolute emergency. Find the 8th term of the sequence. So we have 2/3, comma, 4/9, comma, 8, bless you, 8/27, comma, and the sequence continues. So probably what I would do is I would probably, I mean, you could write these as fractions, or leave them as fractions. I know how much I love fractions. I would probably convert them to decimals and go from there, okay? So how do you convert a fraction to a decimal? Top divided by bottom. What are the right words? Numerator divided by denominator. So in the first one, 2 divided by 3. All right, let's round everything to the same place. So let's round everything to the hundredths place. So this would be 0.67, right? 4/9, 4 divided by 9th. 4 divided by 9th, that'd be 0.44. 8/27, or yeah, 8 divided by 27. If we're rounding it to the hundredths place, would be 0.30. So we have to keep in mind that we're rounding when we find the common ratio, because if it doesn't work out exactly right, we're rounding. So let's keep it in mind. So to find the common ratio, we're going to do 0.44 divided by 0.67. And we get, let's go with 0.6567. And then for the next set, we do 0.30 divided by 0.44. And we get 0.6818. All right, so what I'm thinking is I maybe should have, because when I did this before, I rounded to the thousandths place and I got a little closer, so which is a little more precise. So let's try that. Instead of the hundredths, let's go to the thousandths place. So 2/3, we'll go with 0.6667. Four ninths, that was 0.4444, wasn't it? And 8/27 is 0.29. We'll go 0.2963. Okay. So kind of got a mess here. So this is 0.4444 divided by 0.6667. Bless you. Bless you. And then 0.2963 divided by 0.444 is 0.6667. So if we rounded to the nearest, these two, to the nearest hundredths place, that would be 0.67 and that would be 0.67. So I would say, being that we're rounding, that the common ratio would be 0.67, right? Now, if we left them as fractions and there was no rounding, that would be more precise. Okay, so we have to keep that in mind. That's why you got to be careful with that rounding, because we rounded too soon and it was thrown off. Okay, the further down that you round, the more precise that it's going to be. So we're going to say our common ratio is 0.67. We're going to say our first term in the sequence is 0.67. And we're looking for the 8th term of the sequence. So we're going to take our little formula. So we're looking for a sub 8 equals a sub 1 times common ratio 0.67 raised up to the 8 minus 1. So that's 0.67 times 0.67 raised up to the 7th power. We know we take care of that exponent before multiplication. And I'm going to go with approximately 0.06. Multiply that times 0.67. And I'm going to say 0.0406.
Excuse me.
Yes.
Do you have Rudy?
Yes.
Can you send that student to us, please, for checkout?
Sure.
Thank you.
You're welcome. Anybody have a question on that? All right, so now I'm going to show you what happens when it gets a little bit trickier. And of course, if we wanted to turn that into a fraction, if we were just rounding to the nearest tens place, that would be 4 what? 4 over... What place is the 4 in? What place is the 4 in? Hundredths. So it would be 4 100ths, which would reduce to what? 4 100ths reduces to 2 50ths, which reduces to 1 25th if we rounded to the nearest hundredths place. If we left it like this, that would be 406 over tenths, hundredths, thousandths, 10,000, and then we could reduce from there. So it just kind of depends, okay? But I'm okay if you just leave it as a decimal. All right, now on the next one, we're going to have to put a little bit of extra arm work in. Find the second and third terms of the geometric sequence. Find the second and third terms of the geometric sequence. They're only giving you the first term and the fourth term. They don't give you the second term They don't give you the third term. So they had to tell you it's a geometric sequence. We don't know, what are we multiplying by each time? We have no idea what the common ratio is, right? We're going to have to figure that out, what the common ratio is. We know what the first term is. We don't know what the common ratio is. We know we're trying to find the second and the third term. We're trying to find two different terms. What do you think they are?
Negative 18.
-6
No, negative 18.
and what?
Negative 18.
-6 is correct.
Positive 18.
And +18. Good job. How'd you figure that out so fast?
Oh, I just guessed.
Good guess. Good guess. Okay, so, well, she did it a lot faster than we're going to do it. All right, so what I would do is, first of all, I'm going to write down the formula. A sub n equals A sub 1 times r raised to the n minus 1. Okay, we don't know what the common ratio is. We know what the first term is, right? We know the first term is 2. We don't know what the common ratio is. We know what the fourth term is, okay? So what we're going to have to do is we're going to have to substitute in what we know and go from there. So if we know, usually we put in here what we're trying to find. Well, we need some more information. So if we know what the fourth term is. So we know a sub 4. We don't know r. Right now, our fourth term is negative 54. So our n is negative 54. Or I'm sorry, the fourth term, so n would be 4, not negative 54. My bad. Minus 1. I know that's a mess, and I have no idea where my whiteout is. We would put that negative 54 over here because the fourth term is negative 54. I'll go back and explain that if I need to. Do y'all see what I did there? Okay. I'm just putting in what I know. So now, every variable that I had, I plugged something in just using what I know. Now there's only one variable that I don't know, and I can solve for that variable. That variable that I can solve for is r. That's the common ratio. If I know the common ratio, then that tells me what I'm going to multiply by, and then I can just get the other terms, right? So I just use, I can't plug in 2 for n because 2 was my first term. I already used that. So I had to use the fourth term for n. I couldn't reuse the only other term because I had to use that for the first term. You know what I mean? I couldn't use it twice. So I just used it for n. So let's see. I could, to try to get r by itself, I could divide both sides by 2. So negative 54 divided by 2 gives me negative 27 equals r cubed. If I want to get r by itself, please don't tell me I'm going to divide by 3. What am I going to do? Not square root, but cubed root. So I'm going to take the cubed root of negative 27 and the cubed root of r cubed. Can I take the cubed root of a negative number? No. Square root of a negative is imaginary. But cubed root of a negative. What's negative 3 times negative 3 times negative 3? Negative 27, right? I can take the cubed root, as long as it's a negative index, or I'm sorry, an odd index, I can take an odd root of a negative number. I can't take an even root of a negative, or it's imaginary. So, what's the cubed root of negative 27? Negative 3. And what's the cubed root of r cubed? R. So, our common ratio is negative 3. So if we know that, what must our second term be? -6. So therefore, the second term is -6, and the third term is +18. So I feel like in my notes, I would want a little explanation of what we did here. Wouldn't y'all? Yeah. I know some of y'all would, even if you all wouldn't. So I'm going to try to cram it in up here. I'm going to say, we didn't know the common ratio. We didn't know the common ratio so we substituted what we did know, which was the first term, a sub 1 equals 2, and we knew the fourth term was -54. So n equals 4, and we solve for r. Hopefully that made some sense. I know that's tiny. You want me to reread it? Y'all got it. Everybody cool? All right, let's try another one of those. All right, 214. If I'm going too fast, anybody needs to see my book, you can after we're finished. Find the second term of the geometric sequence. Three, comma, open box, comma, 12. So like on your homework, even if you can just look at it and figure it out, I still won't see your math. Okay? So we don't know what the common ratio is. We're going to have to figure that out. So we're going to have to use what we do know to solve for the common ratio. So we'll just write out our formula. We know our first term is 3, right? We don't know what the common ratio is. We know the third term is 12. So for n, we'll use a what? Well, just for the n, we'll use the 3. N's our term number. A sub n is talking about the third term. So a sub 3 since we know the third term, we'll put a 12 there. Does that make sense? Usually we're looking for that term. That's what we're trying to solve for. But this is, we know it. That is the third term. Like on the last one, we put the negative 54 there because we knew it. Usually that's what we're trying to find. So that will be 12 equals 3 times r squared. Now what? Divide by 3. So 4 equals r squared. Then what? Square root. And r equals 2. And it can actually, because remember I can take the positive or negative square root, it could actually be positive 2 or negative 2. 3 times positive 2 gives me a 6. Three times a negative 2 gives me negative 6. And if it was positive 2, 6 times positive 2 is 12. If it's a negative 2, negative 6 times negative 2 is positive 12. So it could be either positive 2 or negative 2. So a sub 2 equals positive, a sub 2 equals positive or negative 6. It asks for my second term, right? Could be either or. We don't know. If we had a fourth term, we would know if it was positive or negative. It could only be one or the other, but we don't know the fourth term. And square root, if that's an even root, it can be positive or negative. A little tricky. One more of these, then a word problem. Well, am I going to give you the word problem? I don't know. We'll see. Find the missing term of the geometric sequence. We have 4, comma, missing term, comma, 16. I don't know what the common ratio is. I need to find it. I know my first term is 4. I don't know my common ratio. 16 is my third term, so for n, I would just use 3. A sub n, if I'm using a 3 here, this is referring to my third term. So what will I put for a sub n? 16, right? Because this is referring, if I'm using n, a sub 3 would be my third term, so that's 16. Does that make sense? Okay. So that's 16 equals 4 times r squared. Divide by 4. So 4 equals r squared. This is very similar to the one above. I'll be taking the square root, so that I'm going to take the positive and negative square root since it's an even root. So r equals positive or negative 2. So if my common ratio is positive or negative 2, that means the second term is what? Positive 8 or negative 8. So multiply by positive 2 or negative 2. Either way, this would still be a positive 16. Positive 8 times positive 2 is 16. Negative 8 times negative 2 is positive 16. Anybody have questions on that? All good in the neighborhood? Okay. Time for some homework.